Hello, everybody, and welcome to the first webinar in our series of 3 webinars on AI strategy and ecosystem for DV design verification. The presentations, the webinars are from myself, Mike Bartley. I'm a Senior Vice President at Tessolve. I look after COE as Centres of Excellence, where we do a lot of this AI work and a lot of DV research. And my colleague, Marmik Soni. So the outline of what we're going to be covering are AI strategies at Tessolve, design verification flow, which we use that I think is fairly generic across the industry. Marmik will then take over and talk about the classification of our AI ecosystem. He'll talk about some of the tools we use, for example, spec extraction tool to get a feature list. We'll be talking a little bit about retrieval augmented generation. We won't talk too much about that, but we'll share some performance scores, which are how we measure ourselves. We'll look at the challenges, and then key to that is what are the collaboration opportunities, because we do want people to collaborate. Just for background information, we currently collaborate with 3 commercial companies and 2 universities on this work, and it's a very collaborative, and we share what we learn, and we share with them the tools and the results. Okay, so here's our key point of our AI strategy, and that is to make our models replaceable. Now, why do we do that? Because what we found is that the likes of GPT, ChatGPT, for example, will bring out a new model. Maybe it's going from version 1 to version 2 for argument's sake. Okay. Now, what we find is quite often those versions will have a huge jump in performance in terms of its predictability, how fast it can run, how well we can train it, how quickly it can train. There's lots of dimensions where it will improve. So what we want to do all the time is to ensure that our models are replaceable. And we do this by having a database of training data. We record our user prompts. Now, the user prompts are really important to us during the training process. Okay, so that's why we record them. And that means we can automatically replay them. We validate it through an automated test database. And then once we've done that, we can start generating the results. We can start making predictions. We can start generating feature lists. We can start generating cover points. Okay. But then the new model comes along, and what we can do is very quickly drop that in to replace V1. We rerun our training data, we rerun all our user prompts, we quickly validate it through the test data. The quickest we've done that is about 2 or 3 hours from a new release on one of the AI tools that we use to start generating results, and we do see big jumps in improvement. Okay, another key aspect of this is maintaining security. So obviously what you want to do is keep training data secure, our user prompts secure, our test data secure, our results secure, and our model has to be kept secure as well. There is a lot of stories in the industry about how test data can be reversed engineered from a model. So you have to keep your model very secure as well. Very important part of our security strategy. Now, what we've seen is that within our organization, so I'm not just talking about design verification here, but within the whole of our organization, across all our departments, what we found is the users know what type of innovation they want. They're the best people to know what type of automation is going to be best. So what we've done at Tessolve is we have a central AI center that's able to support in what we call innovation at the edge. That means the people working in HR tell us what sort of automation they need, and we can build that for them, and we can help them build it themselves. And we support sales, we support marketing, we support ops, we support recruitment, we support DV. Tessolve has test engineering, it has PCB hardware building, it has software development, and we can help all of those teams improve their performance through efficiency. Now, a lot of that is based around AI. We talk about the AI services which we offer to them, as we say, we enable the edge, we enable innovation at the edge. And that's for AI services. So we can build the automation for them. We can give them guidance on how to build it themselves. Well, we can review what they've done. Okay. Central to all this is actually the software support that goes around it. And you'll see this through all our tooling, that there's software support. And we use, most of the time we're using Python. Python's got very good AI support. It's got very good automation. It's got very good GUI support. It's got very good database support. So a lot of that software is implemented in Python. So if we look at our IP verification flow, this is IP. We're doing something very different on SOC, but you can see this is pretty standard. We take a requirement specification, and from that, we can generate a feature list. From that, we will generate our coverage plan, the functional coverage plan. This is not code coverage plan, this is a functional coverage plan. We tend to generate test benches, then build our test benches. A lot of time, remember, that's manual, and we're trying to automate a lot of these steps. Build test bench agents, our UVC components, our UVM components, our UVCs. We generate tests to start running simulations, and then we add constraints because we want to hit the corner cases. And we're collecting coverage data through simulation, and then we're doing a lot of debug as some of the tests fail. And then we get to coverage closure, and every verification engineer knows that you can hit 90% with 20% of your effort, and then 80% of your effort goes into that final 10%. Coverage closure is still a major issue. Now, where do we put AI in all this? We found that AI is very good feature extraction and coverage planning. When it comes to test bench generation, we do use AI, and you've seen AI give reasonable results, but it's not as sophisticated as we would like, and it doesn't help as much with the coverage closure as we would like. So what we've done is we actually introduced quite a lot of automation scripts in there, and I say that's all done in Python. So what we use the Python for, it generate quite a lot of static parts of the test bench, the infrastructure, the static parts of the UVM, and then it will generate all the dynamic parts, the constraints, the sequence generation, the sequence items that are going to be generated, etc. But what we find we can do is we can actually generate, and that Python uses a config file, by the way. We use a config file for that. So what we can actually do is generate that config file through AI, so we can we can understand the design from the specification, automatically generate a config file, feed that into Python, and the Python then generates this IP. We're starting to do it on SOC, but at the moment we're doing it on IP. And then when you come to the end, coverage closure is still very hard. We do a little bit of additional constraint generation for AI engines based on the coverage database. But a lot of our partners, as I say in this collaboration, are looking at machine learning to do that. Okay, and if you join the collaboration, you'll see a lot more on why that's such a difficult problem. I'm going to hand over to Marmik now. I'll let you take over, Marmik, and I'll turn my camera off. Okay, thank you.
Thank you, Mike. Hello, everyone. We'll be talking about the AI ecosystem first. So as per the requirement and security and cost aspect, we have defined the classification of all the AI ecosystem components like this. So the easy and quick solution that anyone can come up with is the knowledge bots. So for example, the use case that we can take is the UVM chatbot or the functional safety chatbot. So for some of the functional safety engineers, we have created this solution for all the UVM engineers. The solution is created. So this is very easily trained on the publicly available data, and so that is quite security-wise, we can say it is not, because the AI, whatever engineer is using this, they are talking to directly with AI. So security-wise, it is not that crucial. So security is low here, and cost is also low over here. So whatever less confidential data we are having, such kind of use cases can be taken with this kind of knowledge bots. It is faster to deploy and develop. Less efforts is required on this implementation. The second category we can see is the cloud implementation. So here, the faster deployment and faster development is possible here. So when we have some client project, we make sure that the data is being quite confidential with the guarantee that we get from the partner, cloud partner. So here cost is a little higher as compared to the first category, but security is also quite promising over here. So that is the second category we use for different tools and applications. The third category is building locally and deploying locally. So when we talk about this, we can take the model completely offline, like Llama or Orca or those kind of models, which are sitting in our local system, local servers, and it is quite secure. The data is definitely secure. It is completely in our premise, and cost is high. That is the challenge actually. When we are going for such kind of implementation, we'll have to use the high efficiency GPUs. We'll have to use, so upfront cost is going to be higher. So for highly confidential data only, we can do this. It is a little slower to adapt this because when we are having higher number of users or the project numbers is getting increased, their adaptability and scalability is a little challenging in this particular set of solution. The last category is the AI agents that we are using, automation we are using, and the applications that we are building on AI. So few of the applications will be seen in this particular series of webinars. Today, I'll be taking you through one of the tool, and in coming webinars, we'll be going through few more of the tools which are developed in-house at Tessolve by our COE team. So if we talk about the first solution, that is the design verification spec extraction tool. So there we are using the RAG model. So it was a retrieval augmented generation tool. This is the block diagram of that model, how the model work, architecture of the model. So the input is the particular project specification, also the training data about the terminologies and how to read the spec, those kind of training data, and earlier available prompts, all these are getting the training data. So that becomes the fixed structure. The yellow box you are seeing over here, it is a fixed structure. So project spec is depending on the particular IP or the project. Training data is in general training data that we are using from our previous experiences. The prompt character here is giving the solve to the AI that how it is required to behave. What is the expectation from the AI model? So that is the base prompt or character prompt, we can say. For particular for the given project, the user needs to know that what information he is required to generate. So for that, the user input or user prompts are required to be given to the AI model. Also, it is based on the LLM. Here you can see it is not fixed. Why? Because every time with the new spec, with the new project, we are benchmarking the different LLM models and we are changing it by our observation. So that's why whenever some new model is there, as I explained, we are quickly switching to the new model and we are generating the output in the required format. So the flow that we are following so far is like this. When we have the spec PDF, we do the quick review of what is available in spec and what is expected to be generated from that spec. We do the model benchmarking from different models. We choose which model is better suitable for this particular project. Then prompt and response recording. Whatever prompts are being used by the engineer and whatever responses are being generated by the tool, that is being recorded. And that by manual validation. In some of the cases, this particular tool follows the manual validation. In some of the cases, we are also doing the automated validation, as we have seen in the slide number 2. Then after it is getting dumped in the Excel sheet with the confidence score. So AI again tells us that while generating this information, this much sure I am with the generated information. So we have cracked how it is working at the backend. So suppose we talk about the particular phrases being used in the specification, like must, shall, required to, or we take this particular example, the quantitative limits. So somewhere it is mentioning maximum or minimum, at least, at most, or not more than or less than. Then it is defining what should be the upper and lower bound, what should be the range limit of the particular variable, for example, or it is giving us the particular precise limit it is giving. So if we take one example, this is the flow of the description of the description taken from the spec to design the test plan. So this is one similar one example where the data is generated from the AI model. So exactly this is how the tool is looking like, the DV spec extraction tool. On the left hand side, you can see we can upload the specification. Here the PDF pages are available. We can make it wider, or we can reduce the size. Different models which we have used during the benchmarking. We have, as we know, we have plenty of models available in the market right now. So which model is suitable better for our this particular spec? So that can be analyzed with the help of with the help of this tool, and the tool itself is knowing that who is talking to me. So authentication is there with the user, and then after the question can be asked, the prompt can be asked by the engineer, design verification engineer. So this is one of the sample question where it is generating the feature from the AXI protocol. So how it is going to respond? So the tool is responding like this, and from this is getting recorded in the document, and from this whatever information is generated, whatever information is useful, the user can use that, the engineer can use that and dump it into the Excel sheet. So that's the process we follow with this particular tool. Now the question comes, how authentic the RAG model is that we are using, the RAG pipeline is which we are using. So we do two validation. One, the AI is giving us the confidence score, how confident that AI tool is on that particular answer. Second is manual validation. We get the feel when we observe the data, when we know and compare with the PDF manual on the left hand side available in this tool. We get the feel that what is the how genuine the answer is. So two of the confidence scores, manual and automated with AI, is there. Apart from that, we use regularly the different golden data set that we have. So it is a set of question and answer. So those questions are being given to AI solution, and the generated responses from that, from the RAG pipeline, is being compared with the golden answer. And from that, we have defined this 4 criterias for the two for the retrieval part and two for the generation part. So for the retrieval part, it is context precision, context recall. Generation part is faithfulness and the answer relevancy. So from these 4 criteria, we can say that how effective our RAG pipeline is. So as you can see here, we have normally 0.8, beyond 0.8 is always considered a good response. So normally our responses are mapping around on this matrices. Those are mapped around 0.8 to 1. So 1 is best, 0 is worst. So it is reasonably good. So what we do, one sample project if we talk about here. So we start with the spec and the feature extraction we do as I have shown in the earlier table. And so there, C test cases, assembly test cases, cover points, system Verilog assertions, all these things we are trying and experimenting with the help of AI. So what is the input and what are the outputs for that step is mentioned over here for the. So if we talk about just one example, feature extraction, the feature name is there, description is there. AI is also telling us from which page the information is taken, from which section number the information is taken. Also, it is giving the confidence score, how clear the model is that the information is correct. We do the feedback with our partner also, and we also it's a cyclic process. We meet them, they give us the feedback, then we improve what is their requirement, and then the process goes on. So this is the heading of the Excel sheet that we are following for this. Now, what are the important part? What are the challenges here? So initial understanding of the spec is required. It's not like that at this point. We give the spec and it is generating all the information for us. We'll have to have the initial understanding on the specification given to us. The prompting efforts, Gen AI or AI model we have there, the important part is prompt engineering. So prompting efforts are required from the engineer. So it again depends on the expertise. Manual validation. Few of the tools are having manual validation at this point. So that is the challenge. Reliability always is the concern when it comes to AI. We know that we'll have to be very sure on the data getting used, which is generated by AI. So we'll have to be very sure on the reliability part. So if we talk about collaboration once again, these are the different fronts on the design verification where we can collaborate together for like generating the cover points, the test plan generation, the assertion generation. We have already the tool available for this, the feature extraction, unit test bench generation. All these fronts are there. We are also using AI agents these days for writing the test bench. So on all these fronts, we can do the collaboration. If we talk about specifically AI, then these are different research we are doing, like AI agents development, different RAG solutions, tool integration for a particular task, a team of agents we are developing for business analysis and other use cases, AI guided training, chatbots, all these fronts are there where we can collaborate together. So that's it for today. And the next 2 webinars, as you already know, those are on the 20th November and 27th November. And these are the times. So we'll be exploring a few more tools, and I'll be showing you a few other tools where we can check and collaborate together.
Yeah, thank you very much, Marmit. And thank you, everybody.